Good afternoon and welcome back to the workbench. I have here, as you can see, a multimeter of sorts, or more specifically a vacuum tube voltmeter. But it does more than just volts, it also does ohms as well. It's a senior VoltOhmyst WV-98A by RCA Corporation from probably like the 1960s or something. It looks in pretty nice condition, really, at first glance, but it wouldn't be here if there was nothing wrong with it, so I'm going to go into that. I bought this some time ago, several years actually, because I have a high voltage probe that can be used with these, and that lets you measure up to apparently 50,000 volts, which is pretty good if you're checking out, CRT TVs and monitors and other things that use vacuum tubes. And yeah, it's pretty nice. The front panel is in really good condition. The text's all still there. The dial is very nice. Everything's clean. There's no scratches. It's been pretty well looked after. I mean, even the handle is, in pretty good condition. It's not very damaged. It's looks really nice, and the back is pretty good too. I've already taken the screws out, obviously, because I've been into this already. It's got what looks like potentially a brand new cord. Maybe new old stock, not sure. I doubt this is the original, because it's quite possible the original might have been cloth cord or whatever they used to use, or maybe rubber or something, I'm not sure. So this does look like it might be a new replacement, but also the colour sort of suggests that it could be old, but I'm not really sure, honestly. I don't know. It's got a plug on it which looks pretty nice. It does look quite old in terms of style, but I don't know if this could be a new plug or if it's the original. It's got this little sort of cardboard thing on the front there which just lifts off and lets you access the screws for changing the plug. So, and this cardboard is in very good condition, so I'd be surprised if that was the original plug. I think this may have been replaced at some point by the original owner or something. But yeah, it also comes with the standard probe, of course, which I have. It's one of these. It's the WG-299C. It looks in pretty good condition too, to be honest, for its age, so it's really quite good, but it's obviously not perfect. And the the first problem we have here is, here's all the capacitors out of it. It's not really a problem, but these things are like, how old? 50, 60 something years old? They're not very good anymore. They're all sort of paper based and wax based and stuff, and you can see even this one here, the wax is all falling off. So the issue with that is the wax disintegrates, the moisture gets in, the things basically get a high leakage current and eventually short out and blow up. So they do not last. They need to be replaced, these kind of capacitors. These are different. It's an electrolytic one. But again, it's very old, so it makes sense to put a new one in, which I started doing several years ago. We can have a look inside. It's quite nicely built. The back just comes off like that, but we can also see, once we get it open, there is more to the problem than just old capacitors. If we look down the bottom here, where this battery holder is, where a 1.5 volt cell is used for the ohms range, you can see there's a bunch of corrosion down this end where the battery has unfortunately leaked. And I don't know if that happened during transit or before I bought it, but yeah, when it arrived, it had all this leakage everywhere, and the inside of the back case is pretty good. That was easy to clean up. It's just aluminium, and the battery corrosion didn't affect that very much at all. It just kind of discolored it. But we have rust on this bit of metal here, and there's some other issues that have occurred. I can't remember if the battery was still in it when I got it. I think it might have been, but either way, it's not good. So there was that unfortunate problem. These are the wires here that connected to the battery, I believe. So yeah, and we have this range switch which is right next to the battery, and it doesn't look entirely perfect. There's a little bit of discoloration on that too, but hopefully it'll clean up, maybe with some contact cleaner or something. It doesn't actually look corroded, fortunately. Yeah, it doesn't look terrible, to be honest. I think it was spared. There's this kind of strange sort of pink coloration on some of the contacts, but fortunately I think it was mostly okay. Some rust here, and I think I put some rust converter on it at the time, but some of it appears to have come through again, so I might have to retreat that again or something. But that's not really a big issue. The rest of it is very clean, obviously, just like the front. This side, you know, is very nice. The valves and everything, all up there, all the stuff up top is in good condition. You can see where I've actually replaced some of these capacitors already, but I'm going to replace them again. I think at the time I just had these, they were the only ones I had, and I just put these in for testing, but they're on like little bits of wire and they're wobbly around, so I'm going to replace these with some better ones that fit better. But yeah, I also bypassed the selenium rectifier with a standard diode there, because those things like going shorted as well. So we just added like a 1N4007 or something. That's a lot better than that was. I mean, the thing tested okay with a multimeter, but you know, apparently they're not very reliable, and they smell really bad when they blow up. So yeah, I didn't want to risk that. So basically, well, the issue with this here is I need to replace the capacitors again with axial ones that fit in nicer and aren't connected by dodgy bits of wire, and I need to clean up this range switch, possibly. I want to get some contact cleaner in there and work it around anyway. Got to see if it's any good. I mean, if it's completely bad, if it's unfixable, or you know, a total write-off, I suppose I could buy another one of these for parts or something and hopefully get a switch that's actually okay. But yeah, the problem with a lot of these is they're probably all going to have damage in this area, because people often just forget to take the battery out and leave it for 20 years, and then you get this problem. But we also have another issue with it. The range switches do both still work. This one at least moves, which is good. And so does the other one, but you wouldn't expect it not to, because it's the one the furthest away from the battery thing. And we got the zero adjust one. Sorry, this is not particularly well in shot, is it? We got the zero adjust knob, which works but feels kind of weird. It's a bit loose in some places and kind of sticks in others, and it feels worn and doesn't feel good. So and that's going to be the one that's probably adjusted the most, so that could have been just worn out and just old. But the ohms adjust pot is completely seized. It doesn't even turn whatsoever. It only moves slightly because I've undone the nut a little bit. So I need to do something about that, and I think replacing it is probably the best option. Now the thing with these, the fun part about these, is that the bushing size is like 9.5mm or 3/8 of an inch, which is an uncommon size these days, so that's a bit tricky to get, but I did find some on Mouser, so I will be able to replace these with the ones that are the correct size and hopefully the correct value. A bit hard to do that as well, a little bit. But if we come along here to the service manual, or the user manual, which has the schematic and the parts list, which is nice. You know what they used to do back in the old days. One good thing about, you know, that era. What have we got here? Oh yeah, so we've got R7. It's labelled as a variable, 15,000 ohms, quarter of a watt resistor. That's the ohms adjust, I believe. And R13 is the 0. That's a 10k ohm. The only problem is that a 15k ohm pot is basically unobtainium. I could not find one anywhere. I think I found one that you have to order in like a lot of 1,000 or something. And basically, yeah, they just kind of don't exist. And they certainly don't exist in a form factor that makes sense for this piece of equipment. So yeah, it's actually quite fascinating though, because if I measure the one that's in there, right, so I've got that on the 200k ohms range, and if I measure the what is it, the ohms adjust pot, yeah, the ohms adjust pot, if you can just see it in the background, does measure about, it measures 11.1k, 10k basically. So yeah, I think that one is correct. But it's interesting, if you measure the one here, and I can measure that in circuit because it's got, you know, it's not connected in a way that has a problem. This one, the other one, the zero adjust or whatever it is, I'm probably getting them mixed up, but either way, this one down here does have the wiper and one end of the pot connected together, so I actually cut the wire there to be able to measure it properly. But if I do measure it, we actually get 19k. So yeah, kind of fascinating. These things are like the old HP parts, unfortunately. They're not actually marked with their real values, they're just marked with a RCA like original part code. And if you look back on the manual here, you know, you have this list, and you have stock number, and you have these numbers here. So if you were ordering a spare part, you'd ask them for this one, but The numbers on here don't actually match up with the numbers on my unit, so that's kind of annoying. So I don't know if it's just a different serial number, but this is, this is the manual apparently for the WV-98A, and this is what apparently this is, so I'm not sure why, but it could be that they, sometimes parts list and stuff change, schematics change, they forget to update them. But either way, that pot measures as a 20K, basically, or 19K. I mean, it's a 20% tolerance pot, so technically, 15K plus like 3K, it's 18K, so this could be a 15K pot that's high tolerance and maybe gone a bit off because of the corrosion from the battery, possibly. Or maybe it's just a 20K that they had in there all along, because maybe 15Ks are just really hard to get. But I would think that going by the schematic and the way this thing actually is set up, this is the ohms adjust, this is the ohms adjust one here, and it's only connected via these 2 points, one end of the resistor, then the wiper goes to the switch, and this other end shows it as being open circuit on the schematic, but it actually connects back to the wiper. So I think honestly the way they're doing it, it should be actually totally fine to use a 20K. You could probably use a 50K or 100K or anything that's larger than 10K, it's just the adjustment would be more fiddly the higher the resistance you go up, as far as I can tell. So replacing it with a 15K, 20K, it should be fine, but yeah, 15Ks basically don't exist, so I can't get one. But yeah, the issue is to actually get the thing out. So I've found ones that I can order, but I'm trying to figure out how I can actually get the thing apart. I think, and I suppose I could look online, but I think what happens is if you actually unscrew all of these, the 2 switches and the 2 pots, then I think this whole piece of metal here actually will just come off the front, because I think it's actually held in by the 4 controls. I don't think there's any screws or anything. I can't see any in there anyway that I've seen, and kind of like this top bit here is held on by a screw on each side, but we don't need to take that off anyway. And then that basically just bolts onto the front face, which has the meter attached to it. And that's about it. And I don't believe we need to take that off, because you can just unscrew that. It's got terminals that unscrew anyway. There's also what looks like, I think, a resistor down in the front here. I don't know if I can get that in shot. It's kind of inside some heat shrink or plastic tubing, and it doesn't look very good. At first I thought it was an old capacitor, but I think it's actually a resistor, so I'll need to get that out and find out what that is and replace that too, I suppose, because it looks damaged. So yeah, I do need to do a bit of work on this thing, but I think it should be fine, because after I replaced these caps the first time, powered it up, it did seem to basically function. So I think it's probably fixable. The meter movement at least is fine, so that's the main thing. But yeah, the switch, who knows? It looks mostly okay, like I said, but worst case scenario, I might be able to salvage one off off one that maybe has like a broken face and a smashed meter or something that's, not worth very much. But if the switch is okay, just the fun part is just, changing all the little wires. Yeah, I don't know if any of the resistors on this are, out of tolerance or anything. I also need to figure out how to deal with this battery. It's got a kind of holder there, and then there's these wires here with nothing on them. I can't remember if they had anything on them that I cut off, or maybe if they were like that when I got it. I mean, again, this is like 5-6 years ago that I last looked at this thing. I do have the bag of old caps that I pulled out of it, which I kept because it's a good thing to save these, because there's a question about this that I'm interested in. I've got some new axial caps here that I want to put in it some after this, and I've also got a bag with the knobs and the screws in it. I had the screws in, so I've got I've got the 4 screws for the bottom of the case. I've got some kind of washer, which I'm not sure where that came from, and a little broken piece of plastic, which I think has nothing to do with this whatsoever. So that was probably off something else that I was mucking around with at the time. But yeah, there's no battery terminals or bits of wire or anything, and if I had cut something like that off, I would have put it with the other parts, just to remember what I had and what I needed to replace. So yeah, I'm not sure. That might have been already removed when they shipped it to me. What is nice about this though is, even though this is obviously a North American model or product, I don't know if they ever shipped these outside of America at the time, but if you have a look at the schematic again, let me see. yeah, we got this here. So specifications, it shows like what it can measure and everything. I'll go into that in a minute, but it says here power supply. It even shows you the full scale deflection value of the meter, which is 200 microamps, which is nice. But yeah, it says power supply voltage rating 105 to 125 volts, and then more importantly, it says frequency 50/60 cycles per second, so 50-60 hertz. So the great thing about this, I don't need to do anything special with it to make it work on 240 volts, except for plug it into a little step-down transformer that I've got here. And I say that because there's an issue with some of these transformers, and well, not an issue, but this is designed for 60 hertz, like 120 volts nominal in North America, but we have in New Zealand and in most other countries with 240 volts, we have 50 hertz. And sometimes you'll have things where the transformer is not designed to run on a different frequency, and it can actually like overheat and stuff. So the fact that this is spec'd as being both 50 and 60 hertz capable in the manual is a nice sign. But the strange part that I'm confused about, and which I'm probably going to have to ask for some help on the internet for, is the fact that we have like maximum input voltages, and it talks about DC max, 1500 volts, AC volts 1500 volts, peak to peak for sine wave 4200 volts. 2000 volts for other things, and that's what it's rated for. That also shows that on the front there, but what's confusing to me, I think that's all it says there. Yeah, this is all the other stuff. Oh yeah, again we have like RMS value 1500 volts, and peak to peak up to 4.2 kilovolts. I tell you what is cool about this though, I just remembered, is that it says it can measure from 0 to 1000 mega ohms, so this can measure up to a giga ohm, which is really cool, apparently. So yeah, I mean that's another reason why this is a pretty neat little device. It can also measure, I think, AC up to 250 megahertz. If you have the special crystal probe, which I don't have, but I probably never need to do that, but it's interesting that it can do that. But yeah, the strange part is, again, it claims to be able to do up to like 4.2 kilovolts, just as a standard, and peak to peak. But we have a look at C1 here, which is marked as special tubular, whatever that means, but it's only marked as 1000 volts. And if you actually look at the capacitor here, the one that I removed, it says the same thing. All it says is 1000 volts DC on it. So yeah, very confusing. Obviously I can't use this anymore because it's disintegrating. It's got a little clip on it which it bolted to the back of the meter with. That's that little screw terminal there. It just bolted on there to hold it in place. But yeah, I mean that's that's irrelevant to the fact that I don't understand why this is only 1000 volt rated, and yet it says it can do up to 1500 volts, 4200 volts, and we've got that capacitor there. That's C1. That's right directly on the input for, I believe, the AC range. And yeah, it's like I don't understand. They claim it can do 1.5 kilovolts AC, and yet this thing only is rated for 1000 volts. I mean, it says 1000 volt DC on the cap, but it's still confusing. So are they just like pushing that cap harder than it should be, or is the AC rating of the cap different to the DC rating? It's not something that I fully understand, and I guess I'll have to do some research and maybe ask around about that. Now, for example, if I'm looking for a replacement cap for that, because obviously I'll have to, because that other one is like falling apart because it's so old, we have options that are confusing. Like, here's one here, for example. Here's a 0.1 microfarad 1000 volt rated cap, which is what the other one says. And if we go down to the specifications, 1 kilovolt DC is what it's rated at. But the AC rating is only 250 volts. So how does that work? I mean, again, the meter, the manual says like AC voltages with no DC voltage present, RMS for sine waves 1.5 kilovolt. And yet, the rating of this capacitor here, that's only rated as 250 volts AC. So does this original capacitor, even though it says 1000 volts DC, is capable of handling 1.5 thousand volts AC? I have no idea. It doesn't have an AC rating written on it anywhere. It just has temperature rating, 85 degrees C down there. It says 0.1 microfarad. And it's got its little product code thing there. the order code, which obviously you can't order these anymore because that was a million years ago. And yeah, I mean, it doesn't make much sense to me. So yeah, for example, I feel like if I use this capacitor here with a 250 volt AC rating, I think that would break down if you tried to measure 1000 volts with it AC. Not that I would be trying to do that, probably. Like I said, I imagine that if I was using this for anything high voltage, it would be for like the anode connection of a CRT or grid connections or something, and that's you know, DC. There shouldn't be any AC present really at all. But yeah, I mean, we have this other one here, for example. This one costs about 3 times as much. It's rated with 1.5 kilovolt. And in the specifications it says, you know, 1.5 kilovolt DC, 1.5 kilovolt AC, so that should be fine in that regard. It's polypropylene. I think the other one was yeah, polyester, so this one's pretty good. One of these axial ones. But again, I mean, what about this rating? It says peak to peak complex waves 2000 volts, 4200 volts. Yeah, I mean, the capacitor is rated with 1.5 kilovolts, so I guess it can match these specifications, but for the rest, I don't know. I feel like just buying this one because at least it has ratings that match, that exceed the original, as far as I can tell, in both DC and AC rating. It is a bit expensive at 10 volts. I mean, $10. But still, I mean, yeah, it's a high voltage cap. What do you expect? They're going to be expensive. If anyone has any suggestions, let me know it in the comments. So yeah, I guess all I can really do with this at the moment is just replace these caps with the other ones I got that are axial and look nicer and don't flop around, and I can probably start unbolting the front and trying to have a look at if I can get access to those pots to take them out and find out what that resistor down there is. I mean, the problem with the manual, it's got a schematic and it's got a parts list, but it doesn't have like a visual diagram of where each part goes, so I don't know which resistor that is. Otherwise I could just already order it without looking, but I'm going to have to take it off, I guess. Alright, let's get these capacitors out. Now, of course, if this is all you had, you know, they could work perfectly fine. I mean, the voltage rating is okay, the value is correct, everything, but I would just rather have ones that aren't sort of flopping around. Alright. I can reuse these for something else. They've barely been even used, you know. 47 nanofarad, but they just fit in there much nicer and look betterer. Also got this piece of paper here, which has fallen off this resistor. I don't really know why that was on there. It was just sitting over it like that when I got it. Maybe as some kind of insulator, or maybe they forgot to take it off in the factory, but it fell off when I was playing around with it, so yeah, I don't know if that needs to be on there. Anyway, I can fit this one. Let's see, I think that can go there like this. I'm just going to heat this up and poke it through. There we go. Get that in the middle so it looks nice. And then we got that one, which can go in here. There we go. I could put some kind of heat shrink over these leads, but I don't think it really matters. They're not going to move around, they're going to touch anything. It's not really relevant. So anyway, let's just solder these in. Now we can do the other one. And of course, yeah, they often move around when you heat them up, but that's not too hard to correct. We can just grab this with pliers. And then solder in the other side. That looks great. And then obviously just trim off the excess. That looks a bit more nicer and a bit more accurate to sort of originality, I guess, within the bounds of what you can achieve. But yeah, I mean, at least they're axial instead of this kind of thing, which, you know, it works, but it doesn't look as nice. And then there's a couple of caps down here that I also replaced at the time which I've used these red ones there, which honestly, you know, I could probably just leave there. They don't look particularly out of place. What I'd really like to do is start trying to disassemble this thing so I can get at the switch and find out what that resistor is mostly, and get the pots out so I can, you know, put new ones in when I get them. I've replaced the other ones. I mean, they looked nice enough, but I thought I just want to go with sort of something more authentic, axial stuff that, you know, looks like the originals. I don't really know why. It just kind of has a better sort of feel to it. Even though these ones actually look pretty nice in there. These little red ones actually look pretty good, so maybe I should have left them, but these are more useful. I can reuse these on a circuit board somewhere, seeing as they have the radial pins. It kind of makes sense, and I bought these for this anyway, so you know, I might as well use them. These were just ones I had lying around. These are the caps. I took the tubes out, obviously, while working on that, just to make sure I didn't damage them or something. Unlikely, but you never know. Right, so I think what I need to try and do here is take the front off and see if we can actually do that. So these knobs here just pull off the front, which is nice. Oops. We can put those aside. And this knob just pulls off. And then I think we can just undo these nuts. The ones for the pots I've already kind of taken off. And those are in good condition, so I can keep those. So that's all free now, but I think I need to take these out to have them work. So yeah, if I just start undoing these, let's see if this will come off. I don't believe the manual makes any mention about whether or not this is how you do anything to it, but it kind of looks like it because, yeah, everything on the back side is now coming out. So if I just pull on that, yeah, that all starts to come free from here, although it still seems to be attached probably by all the wires that go up to the top on this right hand side, so I might actually need to disconnect this top mounting bracket and take that off the back of the front as well. And I probably need to undo this little clamp that holds the neon indicator for the power light in. I have to take that off, I think. So yeah, and then I should just be able to unscrew those two there. Just need a flat blade screwdriver for that. Take these off. And again, this is also why I've taken the tubes out, because all this mucking around, we don't want to break them. It's possible to crack them or something if we're pulling all this out. And there we go. Yeah, things are starting to come apart now, so it looks like that's how it goes. And then yeah, then the meter just comes off the front there. Caution, the inside surface of this case is coated with a special preparation. Any rubbing will destroy its anti-static properties. Remove dust by blowing with clean air. Now that says the inside of this case, so I think they're talking about the inside of the meter movement under the plastic here, so the inside of this plastic and maybe the backing paper or whatever. I don't think this part's an issue. I think you can touch this bit okay, and it's probably fine. But they're talking like if you disassemble the meter and take all these screws out and take the whole meter off, like if you need to replace it or something, or adjust it or whatever, is to be careful with that. I think that's what that means. I hope that's what that means, but I'm pretty sure that makes sense. I think it would also make sense to put some pair of anti-parallel diodes across that actually for meter protection. Because if there's a fault in the circuit, or there's something goes wrong when you're measuring it, it might, peg the meter out so hard that it burns out the coil or something, which can happen, because again, this thing only works on 200 microamps, there's not much current, so it's easy to wreck these things if you don't if something goes wrong. I might put some protection diodes on that, find out what kind of ones would be suitable. I don't know if, standard like 1M404s would be okay, or if you'd be better off with some kind of small signal diode or something, I'm not sure. Not sure what would be the most suitable for that. Schottky, I don't know. No idea. But I'm sure there are some that are better than others. I can access one of the solder joints down this end. Oh, sorry, you can't even see that. This resistor here, that one there, it's kind of buried inside there in a bit of plastic, and it doesn't look very good. It looks very crusty, and I think corrosion's got into it or something. Or that plastic that's been around it has caused problems. Yeah, there's definitely some corrosion on the brass front of this, but I don't know if it's extended much to the contacts, so that's good. I believe that's the other point where the input capacitor goes, that one there. Position 2 on the switch. But yeah, I'm going to need to desolder that resistor and take it out and see what value it is, and I think I need to replace it because it doesn't look good. And I also need to take these pots out anyway because they're all pretty nasty too. And like I said, this one's completely seized up, and yeah, so it's not good. We need to get all this out anyway. I've managed to get to that resistor, and I've got some clips on it, and it's measuring about 7.1 meg. So I believe that it's R9. Going by where it is on the switch and where it is on the schematic, I think that makes sense. I think it's this one here, R9 there, which is just on that part of the switch there. And if we look at the parts list, R9, it says carbon film 7 meg plus minus 1%, 1 watt. They don't give a voltage rating, unfortunately, but given the size of it, it probably has got a pretty high voltage rating. So yeah, we have to figure out what to put there, but I think it is the correct one, and it's reading approximately what it should read, although, at a 1% tolerance, I'm not sure if 7.1 is within tolerance. I think it might be slightly high, but it's not terrible. Now let's see if I can get the camera in to show this. So yeah, you can kind of see on the front of that brass part of the switch, there's definitely some corrosion there, but I think actually most of the corrosion has just stayed within that area. It looks like the rest of the shaft is actually some kind of phenolic thing or something, so the acid hasn't been able to get up there because it's, so I think the switch contacts all actually look pretty good, and I don't think this resistor has actually suffered any damage from battery leaking either. I think it's just this plastic sleeve around it has kind of started to deteriorate with age. Yeah, the paint on the resistor is all kind of bubbling up and stuff, and this plastic tube is all sticky, and I think it's just disintegrating from old age or something. So yeah, I mean, that's obviously not going to be good for it, and that might be why it's reading high. But then these old carbon resistors, typically go sort of high resistance as they age, and again, I mean, this thing's going to be like 50 years old at least, so, it's not surprising that it's a bit out, but I would say, for longevity, replace it, because it's probably going to be damaged by whatever's leaking out of this plastic, and eventually it may just corrode away and fail and go open circuit. But I'm happy that the switch doesn't look anywhere near as bad as I kind of thought it might have been. Everything looks pretty good. I took out the seized pot. I've got replacements. I can find replacements from Mouser that should fit this. The importance is making sure you get the long 9.5mm bushing, because the front panel of this is actually quite thick, and if you get anything shorter it just won't fit. It also should be 9.5mm diameter, or 3/8 of an inch, to fit the hole. I guess you could put a smaller one in if maybe you put some kind of bushing in there, some sort of shim or something to make the hole smaller. You could probably do that. So that's not a big deal, but the modern ones generally don't have a bushing this long, so it looks like this style I found on Mouser is kind of listed as guitar pots, so it must be the guitar style, which kind of makes sense because that's probably going through like a wooden body on a guitar or something, so you need the long bushing. So yeah, if you're looking for replacements for something like this, try the guitar style, and I think AliExpress has ones like that too, so you might be able to get lucky with those, but they might be audio taper, I'm not sure. if electric guitars use audio or linear type, but I was able to find the ones that I could replace both of these with, so that's good. I should be able to do that. So yeah, I mean that's basically all I can do for now. I just need to try and find a suitable resistor to replace that with. I might order a better capacitor than this one I've got, because I don't know if the voltage rating is high enough to replace this big one here, because yeah, the AC voltage rating is only 250 volts, and I don't know if that's high enough. I think it should be at least 1000, so I might need to get a better one for that. And yeah, aside from that, once I get that done, I'll probably put some protection diodes on the meter, and then I can power it back up once I've replaced all those bits. I'll have to order them and stuff, so it'll take a while. And then I can sort of power it up, do some tests, calibrate it, make sure it's actually working properly, and then we can sort of start looking at all the other resistors, and because some of those might have gone out of tolerance too. Again, just old age. It's the carbon ones, they just kind of fail like that. So yeah, I can do a quick sanity check with like the stuff up here, just measure it on the meter and stuff, make sure it's not ridiculous or open or something. There's nothing much else to do here. I need to order parts, I need to figure out how to get this resistor out. I need to sort of try and clean up some of this corrosion on the switch bushing, and maybe some of the stuff in the front panel of this. Still a bit of like crusty residue there where it's kind of seeped down, but overall actually the damage is not too bad, I think. Oh yeah, and I need to sort of maybe resand the stuff here and reapply the rust killer or something to it. Maybe clean this up a bit. It didn't look like it worked as well as it could have the first time. I did have an old bottle of rust converter that wasn't very good, so that might be why it didn't work. I have a fresh bottle that I bought for doing the power supply transformer that I had elsewhere, so I can probably use that, scrape this off, clean it up again, apply some fresh stuff, and it might work better. But yeah, there we go. This thing is kind of in pieces. I'm just going to have to kind of put it back together a bit and shove it back in the box and put it aside until I can get the new parts in. But at least I managed to get these capacitors replaced for ones that make more sense and look kind of more authentic, the axial style ones. So yeah, that's cool. And I guess yeah, I'll just come back when I've got the new bits for it, and we can find out what happens. So yeah, hopefully that was interesting, hopefully that was useful, and hopefully I can get on to completing this repair soon. See you next time.